Hello everyone, my name is Andres Mafla and I'm a PhD student at Autonomous University of Barcelona. This work, Syntax-Aware Cross-Modal Retrieval, is a joint collaboration between the Computer Vision Center and Neighbor Labs Europe. In this paper, we focus on cross-modal retrieval between images and captions. We consider the following research question. Does incidental syntax help for cross-modal retrieval? We refer to the proposed task as StacMR. As an example, in the figure, the word pizza shows fine-grained and explicit cues that a system can leverage to perform a correct retrieval. Otherwise, this task is almost impossible if syntax is discarded. Previous vision and language tasks employ syntax, such as fine-grained image classification and retrieval, text VQA and STVQA datasets in visual question answering, and in image captioning with the TextCaps and BizWiz datasets. However, it is important to note that these existing datasets contain a big bias that focuses mostly in the syntax information that is present in an image. So in these cases, syntax cannot be considered incidental. A question posed in this work is the following. How relevant is syntax for cross-modal retrieval when it is truly incidental? Answering this question requires a dedicated dataset. The dataset collection began from COCO-Text, a subset of MS COCO with available ground truth syntax annotations that is used for syntax detection and recognition. The images were not collected with text in mind, and thus contain a broad variety of incidental text instances. Our collected dataset, named COCO-Text Captioned, CTC, is obtained by the intersection of images with instances of legible, English, and machine-printed syntax of COCO-Text and the MS COCO Captions dataset. The datasets contain three available modalities: images, captions, and syntax annotations. We collected 10,000 images in CTC. 1.7 thousand of those images have syntax tokens appearing in the captions. We refer to it as the explicit split, which is contained by the full incidental split. Two splits are proposed accordingly, CTC1K and CTC5K, both for training and testing. In our work, we propose two approaches to solve the StacMR task. The first one is applying re-ranking strategies on existing cross-modal retrieval models. A mapping of images and captions is trained to output both representations in a joint embedding space. Similarity is measured by the inner product in the embedding space. On the other branch, we encode syntax and captions to obtain their similarity. Finally, we compute a late semantic combination function to weight each modality and re-rank the captions accordingly. The second approach we present in our paper is a supervised model. The model employs an OCR to extract syntax tokens, embedded in fast text, that are used as input to the text GCN. The visual regions are obtained by employing a faster RCNN pre-trained in visual genome to predict objects and attributes. The visual regions are the input for the visual GCN followed by a GRU to obtain a global image representation. The fusion layer modifies the image features according to the syntax tokens. Finally, we use metric learning from the obtained final features along with the caption generation as an auxiliary task. The model is trained on Flickr 30K, TextCaps, and the validation or training set of CTC. We show experiments with or without the usage of ground truth syntax annotations to show an upper bound. Similarly, we present the best performing models by the re-ranking strategy and the fully supervised one. Additional results showing that our method surpasses current state-of-the-art by using syntax as an additional modality are shown in our paper. We can observe in the obtained results that the syntax provides an explicit fine-grained cue to retrieve the correct image caption pairs in both tasks. Relevant syntax instances that appears in the images and captions is depicted in bold text. To conclude, in this paper, we first propose a new dataset, namely COCO-Text Captioned, CTC, and the StacMR task. We also show a comprehensive set of baselines which build on existing standard cross-modal retrieval approaches. We introduce STARNet, a dedicated trimodal architecture for this task. The main conclusion of our study is that despite the high semantic value of syntax, which can capture fine-grained interactions, it should be used selectively and carefully, only when it is relevant. The dataset and an online demo will be made available at the link or by scanning the QR code. Thank you.